In this video, we are going to talk about the tools that you need to solve problems regarding interest. We'll take a look at simple interest and also get a start on compound interest. So first, let's talk about a couple of terms. Interest is a fee for the use of money. And you can think about this a couple of different ways. You might pay interest if you borrow money, or you might receive interest for loaning money. So if you loan a friend money, say you loaned them $100 and you told them you would loan them that money, but you wanted $10 in interest, then when they paid you back, they would pay you back the amount loaned plus the interest and give you $110. You could also talk about interest in the form of putting money in a savings account. Say you put $500 into a savings account and the bank gave you $10 in interest, then your account balance would be $510. Principal is the term that we use to refer to the original amount invested or borrowed. In these two cases, when you loaned your friend money, $100 is the principal, $10 is the interest. For the savings account, $500 is the principal, $10 is the interest. Simple interest is one way the total interest might be calculated. So we can think of, if we want to know what's the total interest that was paid, if it's simple interest, the formula for that is to multiply the principal times the simple interest rate, this will be expressed as a decimal, times the length of time expressed in years. So we get the formula, interest equals principal times rate times time. Let's stop for just a moment and talk about expressing the simple interest rate as a decimal. So if you're given 4% as the simple interest rate in a problem, we have to convert this 4% to decimals. And this is going to be 0.04. So to convert that percentage to a decimal, all we're doing is moving the decimal over 2 places to the left. It's the same way we always convert percentages to decimals. So if the simple interest rate is 12%, we convert to a decimal to use it in the formula to 0.12. The simple interest rate is 7%. We'll convert it to a decimal, 0.07. We also need to talk about expressing the length of time in years. So if you're told that your loan is 2 years, that's simple enough. We put in the number 2. But if you're told that the length of the loan is, say, 6 months, we have to express this in years. Now, we may intuitively know that 6 months is a half of a year, and that's great if we know that. But to get your time in terms of years, you take the number of months. So say your loan was 7 months, the length of the loan divided by 12. So if the length of the loan is 7 months, for this function, you're going to use 7/12. If it's 8 months, you would use 8/12, which can be reduced by dividing the top and the bottom by 4 your numerator becomes 2, the denominator becomes 3, and 8 months is 2/3 of a year. So let's take a look at how we're going to use this formula. In example 1, you borrow $280 from your aunt for 2 years at 5% simple interest. How much interest will you pay on the loan? Well, that's great. We have this formula. This formula gives us interest paid. So we're just going to use this. We're going to say interest equals principal times rate times time, and we just have to identify these things in our problem. So the principal is the original amount borrowed, $280. The rate we're given is a 5% simple interest rate, and time in this problem is easily given to us in years, 2. So we just substitute principal times the rate. Remember, we had to convert that percentage to a decimal, times time. Working this out, we see that this is 280 times 0.1. The 0.1 means we're just going to move our decimal over on this once. And this is $28. What if the length of this same loan, though, is not 2 years? What if it's 6 months? So we use interest equals principal times rate times time. Principal is still 280. Our rate is still 0.05, but the time is now 6/12, which equals 1/2 of a year, because time has to be represented in years. We can put this into a calculator, or we can work it out by hand. This is going to equal $7. So you can see that reducing the amount of time that it takes you to pay off the loan greatly reduces the amount of interest that you pay. Let's try another example. In this example, you borrow $3,200 from your uncle for 4 years at 6% simple interest. What is the amount you will pay back? So the amount that we pay back is not just the interest. The amount we pay back, let A be amount paid back. A is going to be equal to the interest plus the principal. So first we have to find out what is the interest, and then add that amount to the principal to get the amount you will pay back. So in this problem, we can identify the principal is $3,200. We can identify the interest rate, 6% simple interest, convert it to a decimal, 0.06, and our time is given neatly in years. Let's work this out. So we have 0.06 times 4 gives us 0.24 times 3,200. So 2 times 4 is 8. 2 times 2 is 4. 3 times 4 is 12. 7. So this gives us 768. count over our decimals. There's 1, 2, count from the right, 768. So our interest paid back is 768. So this gives us the interest. And we also know that the principal is 3,200. So A is equal to the interest plus the principal, which is equal to 768 plus 3,200, which is equal to 3,968. This is the answer to example 2. So to recap, compared to example 1, this problem adds an extra step. Since you have to pay back the interest and the principal, you must first find the interest and add it to the principal. So if A is the amount you pay back, then A is equal to the interest plus the principal. Now, I want to talk a little bit about compound interest and get you started on that. We want to talk about what's the difference between simple interest and compound interest. So the way simple interest is calculated, everything's moved. Here we go. That should be better. So the way simple interest is calculated, you are paying the same amount of money in interest each year. So if I handed you $100, so the principal, let's say the principal is 100, and I said, I'll loan you this money at 10% interest. So your rate is 10%. When t equals 0, this is the moment I hand you that money and I say, here's $100. The interest rate is 10% a year. And let's say you immediately hand it back to me and you say, no, I don't want to do that. So then the interest is the principal times the rate times the time, which is 0. So your interest here is 0. The amount paid back is going to be 100 because you handed it back to me, plus the interest. So the amount paid back is 100. If you say yes and you keep the money for a year, your interest is the principal times the rate times the time, and this will be $10. So then the amount paid back is 100 plus the 10 equal to 110. But what if you keep the money for longer? So let's say you keep the money for 2 years. Then the interest is 100 times the rate times 2 years, which is going to be equal to $20. And the amount paid back is 100 plus the 20, or 120. And as we keep going, what you're going to see is that each year, year 3 is 30, and the amount paid back just increases by the same amount each year. So if you don't take the money, you can hand it back to me, it's just 100. If you wait a year, it's 110. 2 years, 120. 3 years, 130. This is simple interest. With compound interest, it works a little bit differently. With compound interest, we can have, let's look at the same principal, $100, at the same rate, 10%. And let's say that this rate is compounded annually. So compound interest is the kind of interest that's used by most of your banks and credit card companies. And interest is compounded, or it's periodically added to the principal. So it starts off the same way. At t equals 0, the amount you would owe would just be the $100 because you didn't keep it. There's no interest. If you keep it a year, the amount you would owe would still be the 100 plus 10% of 100. So 10% of 100, which is going to be equal to, this is 10, so $110. But this is where compound interest changes, because when t equals 2, we're looking at then the amount is calculated differently, because at that point the amount is calculated by taking the previous amount, 110, plus 10% of the previous amount. So we're not going back to the principal like we did here. We're only going to the step before. We're looking at this came from t equals 1, and so does this. We get 10% of 110, which is equal to 121. So this also comes from t equals 1. When t equals 3, the amount you owe is 121 plus 10% of 121, which came here from here at t equals 2. And this is equal to, what is this equal to? 121 plus 12.1, which is going to be equal to 133.1. So you can see that this is a higher amount than what we pay with simple interest because it grows faster. It's growing. So to calculate simple interest so that we don't have to take each step and just keep adding it up, we have this nifty formula. And let's look at what all these pieces mean. So A is the total balance in the account, or the total balance owed after T years. P is still the principal. R is still the annual interest rate as a decimal. N is the number of times per year interest is compounded. So we can compound interest once a year, but we can also compound interest twice a year or 3 times a year, quarterly. So for compound interest, the trick is to just find all of these pieces of information in your word problem and then substitute them into the formula above. A equals P times 1 plus R over N, all to the N times T. So let's try an example. Let's write our formula down. A equals P times 1 plus R over N to the NT. So let's see what we can identify here. You borrowed $3,200 from the bank for 4 years at an interest rate of 6% compounded every 6 months. What is the amount you will pay back? Well, A is going to give us the amount we'll pay back. The principal is $3,200. Four years is our T. The interest rate of 6%, this is going to be our R. And N, we can get the N from this 6 months. So N is, let's go back up, N is the number of times per year interest is compounded. So if we're compounding interest every 6 months, that's twice a year. So N equals 2. So let's plug this all into our formula. The principal, 3,200 times 1 plus R. I'm going to rewrite that percentage as a decimal over N to the N times T. Now, this can be worked out in your calculator, and this will be the answer for this example. It will give you the amount, the total amount that you'll be paying back on this money that you borrowed from the bank. And I want you all to work this out on your own, and then talk to me about it, and we'll make sure everybody's on the right page and getting the right answer. After you do that, I want you to use the same example and figure out what is the interest you will pay in this problem. And to do that, remember that A is equal to I interest plus P, what's this, principal. So we'll get A here, and you can substitute it in for the A. We won't know I. And the principal we have here for 3,200. And then work this out, and we will check our answers all together. Good luck.